What is the difference between Austenitic, Martensitic, Ferritic, and Duplex stainless steel? If you're unsure, you're in the right place. Hello everybody, Erez here and welcome to another episode of the Machining Doctor Classroom. In this episode, we'll break down the differences between the main types of stainless steel and clarify it all. So without further ado, let's join Eric in the classroom.
Thank you, Erez. Hello everybody, let's get right into the matter. Stainless steel has more than 150 distinct compositions. These are divided into four main subgroups: Austenitic, Martensitic, Ferritic, and Duplex. But first, let us examine the key characteristics that differentiate these subgroups. Corrosion resistance is defined as the inherent ability of a material to withstand corrosion damage caused by either oxidation or other chemical reactions. It is measured by millimeters per year and denoted by MPY. We will give a score between 1 and 3 for each subgroup to indicate how well it resists corrosion. The amount of chromium and nickel in the chemical composition is the primary factor affecting corrosion resistance. In combination with oxygen, chromium creates a thin film layer on the steel surface. This layer blocks the oxygen's diffusion to the steel surface, and thus prevents corrosion from spreading into the bulk of the metal. A higher chromium content increases the alloy's corrosion resistance. As you can see on the graph, even a small amount of chromium already gives significant corrosion resistance. And above 10%, the effect flattens. Chromium alone protects only in atmospheric and aqueous environments. Adding nickel improves the resistance also in acidic environments. Additional properties that we will be comparing. Machinability rating. A score in percentage, indicating how hard or easy it is to machine each subgroup. Is it magnetic? Is it heat treatable? Let's start with austenitic stainless steel. Austenitic is the most popular subgroup used in machine shops. The chromium content is between 16 and 20%, and the nickel content is between 6 and 15%. It has excellent corrosion resistance, also in acidic environments. It is not magnetic and cannot be heat treated. The machinability rating is between 35 to 75%. Let's go over the most popular austenitic alloys found in machine shops. 304 is the most popular and versatile stainless steel type. It has good corrosion resistance and still maintains fair machinability. It is easier to machine and cheaper compared to the 316. 303 alloy is the free cutting version of 304. It is the easiest to machine austenitic stainless steel. This is achieved by adding sulfur and selenium to 304. However, it comes with the downside of lower corrosion resistance. 316 alloy is the most popular alloy to use in harsh environments. The main difference between 316 and 304 is that 316 contains more molybdenum. This additive gives 316 excellent heat and corrosion resistance. However, it is the most challenging to machine among the commonly used austenitic alloys. Typical parts made from austenitic stainless are valves and fasteners used in chemically harsh environments, and parts for marine and medical applications.
Sorry to interrupt, but I want to emphasize a point. Too often I see parts being sent to production with a requirement for stainless 316 when it is not necessary. Some engineers simply copy and paste without considering the implications. The cost of the part increases 3 times. The raw material is more expensive, the tool life of the cutting tools is shorter, and the cutting speeds are lower, which result in a longer cycle time. The overall effect is dramatic. If you are a part designer, think twice. If you are from production, don't be shy and ask the engineers if they can settle for 304 or maybe even a 303. Please leave a comment and tell me if you agree or disagree. And now, back to the lesson.
Martensitic stainless steel is the second subgroup in terms of popularity. Martensitic alloys have a chromium content of up to 14%, with almost no nickel. It has corrosion resistance only in atmospheric conditions, and cannot be used in harsh environments. They are magnetic and can be heat-treated to a hardness level of up to 60 HRC. Therefore, alloys in this subgroup can provide very high strength. The machinability rating is between 40 to 75%. The most popular alloys in this group are 420 and 440. Typical parts made from martensitic stainless are razor blades, surgical instruments, and other parts that require higher strength, but are less critical in corrosion resistance. Ferritic stainless steel materials have a chromium content of up to 16%, with almost no nickel. They have better corrosion resistance than martensitic alloys, but less than austenitic ones. They are magnetic, but cannot be heat-treated, and therefore, they cannot compete with martensitic alloys in terms of strength. Their machinability ranges between 40 to 75%. The most popular alloys in this group are 430 and 409. Typical parts made from ferritic stainless are auto exhausts, grills, coffee machine parts, and other household appliances. Duplex stainless steel alloys have a two-phase, austenitic ferritic structure. They benefit from the advantages of both austenitic and ferritic properties, leading to increased strength, higher toughness, and broader corrosion resistance. Chromium content can reach 30%, much higher than austenitic alloys. The nickel content is between 4 and 7%. Duplex alloys are non-magnetic and cannot be heat-treated. They provide higher corrosion resistance and tensile strength relative to austenitic alloys. This comes with the price of very poor machinability, between 20 to 30%. The most popular duplex alloys are alloy 2205, also called F51, and alloy 2707, also called A276. Popular applications, where duplex stainless is used, are paper production, desalination of seawater, and oil and gas parts. Now, let's go back to Erez for a brief summary.
Thank you, Eric, and thank you all for watching. I hope you learned something new today. In future classroom episodes, we'll look deeper into each subgroup. Be sure to subscribe and follow so you don't miss new episodes in our classroom series tackling common technical issues. Bye!